Okay, we are looking at lesson 88 here today. And it says remainders in stories about equal groups. So let's look and see what this is all about. We'll take some time to walk through lesson 88 together. As always, there are some warm-up questions right here, so spend some time looking at these. Always important to kind of review what you've done, and that will help you kind of get back into the swing of things here, especially if you haven't done some lessons for a while. But take some time to warm up your mathematical mind, and then we'll jump into the new concept. Okay, today's new concept, it says here we have practiced equal groups problems that we solved by division. So basically that's the idea of taking something and dividing it into equal groups. In these problems there were no remainders. In other words, you didn't have anything left over. It divided out perfectly into a certain number of equal groups. In this lesson we will begin practicing division word problems that involve remainders. Remainders just means you have something remaining after you divide it into equal groups. It doesn't divide perfectly. When solving these problems, we must be careful to identify exactly what the question is asking. And that's true for any question, any type of problem. You really want to be very careful and make sure that you are looking, focusing on what the problem is asking and then making sure you're answering that question. Okay? So here's an example. It says the packer needs to place 100 bottles into boxes that hold 6 bottles each. So notice as I'm reading through this, I'm kind of underlining or circling some things that kind of draw my attention, things that I feel like I should focus on. So there are 100 bottles, and he's going to put these into boxes, and each box holds 6 bottles. So if you can imagine, sometimes it helps to maybe draw a little diagram, but you've got a box, and that box is going to hold 6 bottles, and then another box, and that one's going to hold 6 bottles as well. So there's going to be box after box after box after box, each box holding 6 bottles. And you have a total of 100 bottles that you need to place into these boxes. So it says how many boxes can be filled. Notice the word filled there. How many bottles will be left over? In other words, there's no room for them in the boxes that you have. And then how many boxes are needed to hold all the bottles. So let's look at this. So what you're going to do is you're going to take the 100 bottles and you're going to divide that 100. Imagine this is all 100 here. 100 bottles, you're going to divide them into boxes. So you have to figure out how you're going to equally divide them into groups. And each group is 6. So each box or each group is 6. So you have a box of 6, a box of 6, a box of 6, another box of 6, and so on and so on and so on. So the mathematical operation here is taking your 100 bottles and dividing it by 6. And you can see the operation is being shown to you down here. So if you take 100 and you divide it by 6, this is your long division. So you first look at maybe the first 2 digits there, which give you a 10. So does 6 go into 10? Yes, it goes into 10 one time. So we have 1 times 6, and then you do your subtraction. 10 minus 6 is 4. And you bring down the next digit in the number. So that would be a 0. So you have 40. Does 6 go into 40? Yes, not evenly, but it goes in 6 times. So that's how they get the 6 here. 6 times 6 is 36. Subtract, you get 4. And notice you can just keep going on and on and on and on and on, and you're just going to keep getting the remainder of 4 all the time. So this is showing us that you have 16, and then there are 4 bottles that don't fit into a box like the others. In other words, you have 4 remaining bottles that are left over. So you're going to have 16 boxes. 16 boxes, and then you've got 4 remaining bottles. So that is telling us that these 100 bottles can fit into 16 boxes, because 6 times 16, if you do this here, 6 times 16 is going to give you 96. So 96 of the bottles are going to fit into boxes evenly, into equal groups, into those boxes, but then you're going to have those 4 remaining ones that are not going to fill up the box. Okay? So to answer all these questions, how many boxes can be filled? 16. How many boxes left over? 4. And then how many boxes are needed to hold all the bottles? Well, you're going to need 16 plus 1 more to put those remaining 4 in. That last 17th box, that last box is not going to be full. It's only going to have 4 in it. But you're going to need 17 boxes in order to hold all of the bottles. And there'll be a space for 2 more bottles in that 17th box. Okay? So I just answered all the questions right there for you. Let's look at some practice sets here, or some practice problems. It says tomorrow 32 students are going on a field trip. Each car can carry 5 students. So it's asking how many cars you need, how many cars will be filled, and let's look at all of these questions here. So 32 students, each car can hold 5. Now if you wanted to, you could just say, okay, this car holds 5, this car holds 5, 5, 5, 5, and you'll notice here you're going to end up getting 5 plus 5 plus 5 plus 5 plus 5 plus 5. There's 6 5s there, and that would give you a total of 30. Well, that means you need to put 32 students in there. So right here, right now, you've got 6 cars, 5 each, for a total of 30 students. But that means 2 students are either going to stay behind, or you got to find another car for those 2 remaining students. So you're going to have how many cars are filled. That would be 6, and then you're going to have 2 more students that still need some transportation. So you're going to have to find another vehicle. So how many cars do you need in total? You're going to need 7. So 6 cars are full, and then the 2 remaining students go into the 7th car. How many stacks of 4 quarters did he make? Oh, let's look at here. There's another problem here. Okay. Rafiq found 31 quarters in his bank. He made stacks of 4 quarters each. So you're going to make a stack of 4, another 4, another 4, another 4, another 4. You see these equal groups here? That's basically what we're doing. You're basically taking 31 and you're dividing it by 4. How many stacks of 4 can you get? So you can think of it this way, by looking at kind of like a diagram and repeating 4s, or you take 31 divided by 4. Let's do the division this time. So 31 divided by 4, you're going to get 7. 7 times 4 is 28. 7 times 4 is 28. You subtract these 2 and you get a remainder of 3. So you're going to put a big R there with a 3. So that means you've got 7 stacks. I could keep doing this over here. 1, 2, 3, 4, 5, 6, 7 stacks. That gives me a total of 28. But I have 31 quarters. So you've got 3 that are remaining. How many stacks? 7. How many extra quarters? 3 remaining. Okay? If Rafiq made a short stack with the extra quarters, how many stacks would he have in all? Well, these 3 remaining quarters are going to go into a stack by themselves, so that means you'd have 1, 2, 3, 4, 5, 6, 7, and then that remaining short stack, they called it, so there are 8 stacks altogether. Okay? Alright. The problem set here, I'll just make a couple comments as we go through these, but you might want to pause the video at this point and then go through this mixed practice. Practice it. Show your work step by step, so that you are avoiding any mistakes and you are kind of forcing your mind to work through the different steps that are required in order to solve these problems. It's a good problem-solving technique to write down what you're thinking. Okay? So let's make just a couple comments here. Again, you can pause right now, do the mixed practice problems, and then come back and look at my comments. Peter packed 6 table tennis balls in each package. There were 100 table tennis balls to pack. So this is already the lesson that we just talked about. And you're going to take the 100 table tennis balls and pack them into a package that holds 6. So you're going to take your 100 and divide by 6, and then you should be able to answer those two questions. 123 is how much less than 321. So how much less? How much less right there is the key phrase. This should be difference or subtraction. Okay? So 123 is how much less than 321. You want to take the larger number minus the smaller number. Number 3. Brooke bought 4 giant pretzels priced at 59 cents each. Don't miss that. 4 at 59 each. The sales tax was 16 cents. What was the total cost of the pretzels? So you've got 59 each, 59 cents times 4, and then once you figure out what that value is, you're going to add on the 16 cents to find out what your total cost is. 24 inches is how many feet? Well, you need to know how many inches are in 1 foot. There are 12 inches in 1 foot. So if you've got 24 inches, you're going to take 24, since 12 inches is 1 foot, you take 24, divide by 12, and you see that you get 2 feet. Another way to write this would be to take your 24 inches, write that first, and then use this unit multiplier or this conversion in order to convert to feet. So 24 inches, and then I put the inches in the denominator because that's what I want to cancel. Feet would go in the numerator because that's what I want to go to, and then I write in these two values. 1 foot is 12 inches. So that shows me that I'm going to take 24 inches, or 24 over 1, and if I multiply this straight across, it's 24 times 1, 24 times 1, 1 times 12, and it's really going to be just 24 divided by 12, because 24 times 1 is 24, 1 times 12 is 12, 24 divided by 12 is 2, and since the units of inches cancel, your units now are feet. Okay, 2 feet. Number 5, segment YZ is how many millimeters long. So YZ, make sure you look at this carefully, YZ, so you're going to go from 40 up to 80. So from 40 up to 80, and this is in millimeters, so from 40 up to 80, you just subtract those two, always larger minus smaller, and you find out the distance of YZ. Segment YZ is how many centimeters long? Well, every centimeter, this is going to be 10 millimeters is 1 centimeter. So this is 1 centimeter. This would be 2 centimeters. So every 10 centimeters is every 10 millimeters is a centimeter. So this is going to be, if this is 40 millimeters, then that's going to be 4 centimeters. Okay, 1, 2, 3, 4. It is morning. What time will it be 5 hours 20 minutes from now? So you want to add on, sometimes you can add on the minutes here. So if you take the 20 minutes and you add 20 minutes, this is 7, looks like 7:03. If you add 20 minutes, now we're at 7:23. And then if you add 5 minutes, 5 hours, 5 hours to that is going to be 7 and 5 is going to give me 12, right? So it's 12:23, and that would actually be afternoon or PM. Okay, write the number in expanded form, 7,528, then use words to write the number. So 7,000, that means actually 7 times 1,000 plus 5 times 100 plus 2 times 10 plus 8 times 1. That's what that actually means. When you put those digits in a specific place, they actually have specific values. Okay, and then the words here you can probably figure out. 7,528 7,528. Number 8, 1/5 of the 25 band members missed the note. How many band members missed the note? So 1/5 of 25. So if you've got 25 here, let's say you have a diagram that represents 25, and 1/5 means you're going to divide that into 5 equal parts, or you're going to divide it by 5. So 25 divided by 5 gives you 5. Or you can take 1/5 times 25. It's the same thing, and you end up getting 5. So 1/5 of 25 is 5. This time it's asking what percent of the band members in problem 8 missed the note. So percent means what percent is 1/5? 1/5 is equal to what percent? Well, there's a couple ways you can approach this. You can take 1 divided by 5, okay? Or you can take and figure out what over 100 is equal to 1/5, because that's what percent means. It means per 100. So what over 100 is equal to 1/5, okay? You can think of it like this. If you take 1, now 1 divided by 5, 5 doesn't go into 1, so I have to continue this and put 1.0. So now I'm looking at, does 5 go into 10? Yes. 5 didn't go into 1. Make sure you carry and put that, not carry, but put that decimal point right above there. And does 5 go into 10? Yes, 2 times with no remainder. So that's 0.20. So 0.20 means 20 hundredths. So it's 20%. Okay? And you can do that here with the proportion as well. And you're trying to figure out 5 times what gives you 100? That's 20. So you take 1 times 20 to give you that x value right there, that unknown percent. So again, either way is going to give you 20%. Okay, you should be able to do these. These are all good practice. You want to make sure that you are keeping your mathematical operations skill finely tuned. So don't neglect these. Do all of these problems, 10, 11, 12, 13 through 24. All of those operations you should be able to do. Let's look at number 25 and 26. These are actually setting you up for some algebra later on. Notice you've got a letter here instead of numbers, but you can solve for that letter. You can find out what that letter is, and let's look at this and walk through this step by step. So you have 7 plus 7 over here on this side. 7 plus 7 is 14. You don't know what that n is yet, so just leave it there. 7 times 7, 7 squared. 7 squared means 7 times 7. 7 times 7 is 49. So that's 49. And now you're saying 14 plus something is equal to 49. So you have to figure out what that something is. What plus 14 is going to give me 49? Well, another way to think of it is 49 minus that 14 will give me the missing number. Okay? Over here you've got 3 times something is equal to 6 squared. 6 squared means 6 times 6, which is 36. So now you're saying 3 times what gives me 36? 3 times what gives me 36? Well, since you don't know what n is, but you do have the 36th and the 3, you can think of it this way. You can say 3 times something equals 36, so that means 36 divided by 3 would give me that missing number, which in this case is going to be 12. Okay? Draw an obtuse triangle. Obtuse means that all of the angles are greater. Sorry, it has not all the angles. It has an angle that is greater than 90 degrees. So as long as you draw a triangle and one of the angles, like that one right there, is greater than 90, then it's an obtuse triangle. The classroom was 40 feet long and 30 feet wide, as the drawing shows here. How many 1 foot square square floor tiles were needed to cover the floor. So each of the tiles here are going to be 1 by 1. 1 by 1 by 1 by 1. So you're going to need 40 of them are going to go across the width, and 30 rows are going to go down this way. So 40 times 30 is going to give you how many square tiles you need, and that's what area is. So you need to take 40 times 30. Now you notice both of these end in 0. So really you could just take 4 times 3, which is 12, and then add 2 zeros at the end, 1200 square tiles, and we write this as square feet. Okay? In this polygon, which side appears to be parallel to side AD? So let's find AD. This is side AD. The side that's parallel to it would be, across from it here, would be side BC. And last one, we have a graph. According to this line graph, Sean's score improved by how many answers from test 1 to test 2? So let's look at test 1. Test 2. Here's the value for test 1. It looks like it's right in the middle between 14 and 15, so that'd be, 14 and 16, so that'd be 15. Test 2 is here. That's 18. So he went from a 15 up to an 18. So he improved by 3. Okay? His score improved by 3 answers looking at the line graph. Okay? Alright, so I hope that's helpful. And if you need to, go back and review these again and be prepared for the next lesson. So keep up the good work.